Artificial intelligence and machine learning are often talked about as these tools that can solve just about any problem and find insights far beyond what humans can. While AI is an incredible tool that has contributed to breakthroughs in many disciplines and is helping to create safer environments, it's the people collecting and analyzing those outputs that really matter. We're being joined by two folks using AI and ML to shape technology and data sciences today. John Harkness is the co-founder and CEO of Rewire Neuro Inc., an Oregon bioscience startup that provides an artificial intelligence platform for biomedical image analysis. John received his doctorate in neuroscience from Oregon Health and Science University in 2015 and began developing AI technologies during his postdoctoral fellowship at Washington State University. He continues to provide support for entrepreneurial-minded students as a business development consultant in WSU's Office of Commercialization and through Washington State University's Entrepreneurial Faculty Association. Jonathan Lovegrove is an engineer and entrepreneur that founded IND Incorporated. IND specializes in custom-engineered solutions across the manufacturing and production spectrum to the high-tech industry. Jonathan maintains a very active role in development and teaching of new technologies for the high-tech industries, as well as helping build a tech community in Southwest Washington. Let's turn now to hear what these experts have to say about how we can prepare to work in these fields.
My name is Jonathan Lovegrove. I work in the field of AI, ML, and have a couple of companies working on that science, that technology. And
I'm John Harkness. I'm the CEO of Rewire Neuro. We are an AI as a service platform in the biomedical image space. And so I'm happy to be here with you today, Jonathan, to talk a little bit more about AI and application of AI in some of these spaces.
Likewise, John. Thanks very much. Should be a good conversation. Yeah. So I think one of the subjects was just for the students watching is why should they be interested in AI and what is it going to mean for their careers? Is it useful? Or?
Yeah, I think it's a good place to start. You know, for myself, my background is not in AI at all. You know, I'm trained as a neuroscientist. I went to grad school for neuroscience, and so I'm really heavy on the biology side. Came out of school, and really found an interest in this. This is such a hot place to be working right now. But now, having looked back, I would have loved to have just a little bit more exposure to that. Of course, I'm old enough. That really wasn't an option in a lot of school. But I think that's one of those things that people can come out now with, some exposure to just, what's possible, where AI is going, and figuring out ways to apply it.
Well, it's a new tool, isn't it? It wasn't there. Same thing for me. I came from the engineering background, and everything was electronic or software, but not truly ML or AI yet, right? They were just computer programs.
Yeah.
They weren't nearly as advanced. So it's a new tool, and we've got to learn how to use it.
Yeah.
Figure out where it's useful and where it's not.
Right. Yeah. Exactly. And I think the democratization of this as a tool has been really powerful, just because now it's something that is a little bit more approachable. One of the ways that I got into this was just messing around with some of the tools on AWS. Right. Everything we do is computer vision, and AWS is really excited to teach you how to train computer vision models on SageMaker or something like that. And those are the some of the opportunities that I think now exist that didn't 10 years ago.
Yeah, you mean from like an accessibility standpoint,
Exactly.
right? It's not out of reach anymore. There's some great tools out there. Google have a lot of NLP tools that are available and very accessible.
Yeah.
Which is really exciting because now people can put their hands on it and actually try and apply it to different areas and find out where there's a value.
Yeah.
If you do it that way, and or come up with a problem statement and then try and find the solution is a different way, right?
Yeah, you're right. To find, I think, the different interests in AI and ML, right? Because NLP, computer vision, self-driving, maybe being a subfield of that, are all things that I think people can explore fairly easily now through some of those tools, just online resources, and then kind of continue down the path that's interesting. But Yeah, I sure wish we had that when I was in college.
Well, it's an interesting thing. I think there's a little bit of a pro and con there in that if you know what tools are available, it's really important to know what tools are available because you don't know how to solve a problem without the certain tools, right? But it also becomes a little bit of a restriction because you end up trying to solve the problem with only the tools you have at hand.
Yeah.
Right, where sometimes if you're being really creative, if you're really pushing the boundaries, the tools don't exist yet.
Yeah.
You have to build them.
Yeah.
Which we can get into later on, but that's a much deeper challenge. But I do think that the basic understanding of the tools at hand is good.
Well, that's a good point because when we are hiring AI or ML engineers to come onto our team, a lot of the times what we'll see is somebody with a whole lot of experience, in just training, let's say, computer vision models, and that's a really useful person to have on board, especially just to be efficient, to help drive some of those technologies forward. But that ends up, being challenging to introduce them to, this really like nuanced or particular niche that we are in, without any background previously in that. So, that's what we're often looking for in a new hire is somebody that has those tools, is capable of training up some of these technologies that we're interested in, but understands why we're doing it. Because that bigger problem is ultimately the hard part. A lot of people can go use SageMaker and train, an object detection model, but knowing how to do that for a particular workflow, for a particular problem is I think, really the hard part.
Well, and understanding the tools you're working with, right? It's like the age-old saying, you're going to be smarter than the tools you're working with.
Yeah.
You have to understand, if you're using a particular tool, how it's working.
Yeah.
It's there to speed things up for you. It's able to do some things for you maybe you couldn't. But understanding how it's working is really valuable because a lot of the times, I don't know if you've found the same thing, but there is rarely a single AI solution.
Yeah.
Most of the time it's a stack, right? And
Exactly.
It starts with ML, and then there's this layered approach that finally, on the last layer, you get the output.
Yeah, it's kind of a funny, I think part of the growth of this technology now, because it's gone beyond just a buzzword. It's like, oh, you're creating AI. Now, it's like I'm applying this in a particular part of our problem. We are building a solution that incorporates AI, in our case, to detect cells or, to detect a part of an image. And that really only helps us get through, finding it, and then we have to do all this stuff to analyze the image and put it into the right place, give it into the right shape, to the customer, and that, is everything else on top of AI.
I was chatting with somebody just recently. They're like, "Oh, well, we just plugged it into AI, right? I mean, you do that. You just feed it in, it spits out the answer." I'm like,
Little AI dust.
Yeah, exactly.
Sprinkle that on top.
It's like, no, there were days of data prep before that and
Yeah.
data cleaning up and just making sure that it was going to be ingested properly. And then you run it through the AI engine, and then you got to analyze the results. Right now, you just got a ton more data. It's in a different format, but what is that?
Exactly.
It's not a magic.
No. I was just in a conversation the other day with someone, trying to figure out a solution for them, and I was like, well, yeah, can you just make the AI do this? It will clean up the image, it will process the image. I'm like, whoa. We need to. I think that is one of the the interesting points that we're at is like, if I can define a very specific problem, it's usually pretty easy to train up. In our case, some computer vision that will find that target. But if you don't know what you're looking for, if you can't define what you want this program to do, then you're really just going down a rabbit hole. You're never going to be able to create an AI that's solving your problem for you.
Well, again, it's rarely one, right? Image processing, you might have to do some noise reduction first.
Yeah.
Well, that's an AI in itself. You're just taking raw images and cleaning them up without losing any data. That's another that's another rabbit hole, right? And then processing. But there could be a whole stack there. Actually, that's an interesting one as well. It's just on the data. Something really important for anybody listening to this is please don't clean the data.
Yeah.
Before cleaning the data, the zeros are just as important as the ones.
Yep.
And if you get rid of all the zeros, you've really got nothing.
Creating those biases right at the very beginning.
Yes, that's right.
We've run into that on a number of projects, to the point where we've tried to add like noise back in, after an image has been cleaned. Because,
oh, really?
Yeah, if all your processing is signal, and then you get into the field and that's not the case, of course your model's going to fall down and it's not going to be able to work in real time.
And consistency as well, right? That's something else I found in the data itself is margin of error is acceptable because you can adjust for that. And AI's, with any data flow, it's kind of hard to say, let's say something neurological, right? You've got a data input and it's got a large margin of error. That's kind of okay, right? The AI is not going to pick out, it's not going to magically get rid of the margin of error for you. But what it's really good at is finding trends in that data. So you can have a pretty wide band margin of error. If you've got enough data, raw data, dirty data is okay, because the AI will find the trends, and the trends are very accurate.
Yeah, right? I think that's exactly right. And you've run into that, I know, with some of the stuff that you're doing, talking about some of the large data sets that you guys are now processing. I mean, it sounds like that brings in a whole new layer of being able to manage the data set, understanding how to work with big data, and then trying to do something useful with it.
Yes, it is a challenge. When you start off with 10,000 rows, 100,000 rows, maybe 1 million rows, it's manageable on the compute platforms that we have available today. But you get into the 50 million, 100 million plus rows, it's a new challenge, right? You can't just load it onto there's no one single machine that'll handle it. So then being able to chew that and then, of course, process it efficiently. Because to be able to train once and then just apply everything to the model, to the training model is fine. But if you're doing it live and you're having to update that training model on a fairly high frequency, then computational cycles are super critical, right?
So when you're hiring ML engineers, what are you looking for? Because you're finding a slightly different person than I am. I'm looking for that person with computer vision experience. You're looking for experience with all different types of data sets, right?
Yeah, maybe mine's a little bit more unique. I like somebody who really can think outside the box, somebody really creative, because I think that's the part of the passion of it, right? There's two different ways. You can say, okay, this is a career. It's what I'm going to do from 8 to 5 every day. I'm going to do this, and then I'm going to go play hockey or diving or whatever you want to do, right? The other one is, no, I actually have a passion for this. And manipulating and mastering the data and getting an output is something I take a lot of joy in. That stimulates another level of thinking, right? You can't really let go, right? You're not working, you're off the clock, but you're still enjoying like a good chess game or something. You're still thinking, I gotta get around that somehow. There's gotta be some
it's
method.
Kind of that like spark that you really want to chase the solution, figure it out. Yeah, absolutely.
Which is what I was saying going back to the toolkit. And I think if somebody's looking for a career in it, then the idea is being really proficient with the toolkit you're provided, right? Because if it's a larger corporation, you can't have 200 creative thinkers. Somebody's got to somebody's actually got to put the wheels to the road and make something work. But there's proficiency with the tools that you've got. So as you said, with your models, you need somebody who's really good at image processing or training on image.
And with a small team, we're a small team. We're a startup of about 12 people, and that's nice because everyone gets to wear a lot of hats. But I think that is hard, sometimes, especially if you've been in a bigger organization where you're used to kind of that really structured workflow. It's definitely a different life. I think everyone kind of has to live and die by the team in an AI, right? In a startup, because we are all trying to push a boulder up a hill, and that isn't usually just somewhere where you can clock in and clock out.
And I wouldn't talk people into that any more than I talk them out of it, right? There's just different paths, right? And I think if I were to do it again, well, maybe not myself, but I know other people that are really well suited and are fantastic at just getting stuff done, right? It's just getting it done as efficiently as possible, error-free, just first case. And they are masters at every tool they bring on. Now we have Rust instead of, it's like, okay, another tool.
Yeah.
Okay, do I learn that again?
Yeah.
Do we stick with C++? Is Python still going to be valid? Don't know.
But the reward of getting to like do that thinking, like taking ownership of a solution, not just having to clock in and clock out, I think is the attraction, right? Having ownership over what you're doing and getting to build something rather than just follow instructions.
That's an interesting one, especially in today's age, right? With the work from home and a more unstructured workplace and work hours, right? Where it's more productivity, and you're paid for productivity. Another example there showing proficiency in the tool set gains you a higher quality of life.
Yeah.
Because if you're really good with the tools and really proficient and really fast, you might be able to get the 8-hour job done
and you can go
and
out
still,
and enjoy your
still go for a
afternoon, enjoy the
walk
sun.
or something.
Yeah.
And whereas somebody who's struggling with the tool set and didn't invest in the learning curve that's required to be proficient at that is going to struggle. They might have to be putting in a lot more work.
That's a really good point.
Output.
Yeah. So it seems like it's a balance of finding the job that matches your personality, having a tool set that allows you to be productive in that environment, and then probably having some outside dynamic to you that's making you an important part of the team. What differentiates you from somebody else who's also gone through an AI class or something like that.
I would hope that people find, no matter what path they choose, or discipline, is that being a valued part of the team, you don't have to be the creative thinker or the most productive coder to be the most valuable part of the team, right? There's everything in between, and everybody should be an important part of the team. Because the other thing is, on each one, right, you end up being a specialist. So you mentioned an image expert, somebody who's really good at training, for example. Well, if they don't understand the next link in the chain, it's hard for them to, unless you've got a really good PM, and everybody's just leaning on the PM to do all the coordination, but it's far better for the team to have a broader understanding of the whole kind of organic project.
Totally. I mean, we a lot of the problems that we encounter in our solution development are really, shaping the data prior to the AI or doing something with it after, right? You need to take, just all these different things that people are throwing at you and get it into a shape that works for you. So finding that solution, thinking, if my AI or ML engineer is able to kind of see where we're going, what's the end product, the output that we're delivering back to the customer, that helps a lot with our solution development rather than, just kind of like, I generated detections for you. Now you go program that into something, because that ends up with a lot of kind of loose ends or dead ends, I think in our development.
And I think that's what separates big corporations from smaller operations as well, is that as a small company, you have to have that broader understanding, right? It's like, why is the customer sending us scruffy information to work on them?
Right.
It needs a lot of that pre-processing. Well, if you understand their world better, you'll understand that they can't do much better.
Yeah.
So there's no point saying, well, we just need better data to work with.
And they may not understand the difference between AI dust and real AI, real ML.
Yes, yeah. So another question for you. AI versus ML. What are your thoughts on the differences there?
That's a good question.
If there is one.
Well, I mean, they both get thrown around a lot. And, I think kind of at the surface level, it really just comes down to the audience that I'm talking to some extent. If I'm talking to, our customers or, sometimes our investors, it's not as much about the specific technology, but, the application of it. And, what we are doing is very much machine learning. We are, developing systems that are, intelligently incorporating data into a solution without coding every step of it. We're making decisions based off of the data that are coming in. And, that's using a lot of like deep learning methods, which I think, often are very well categorized in kind of the machine learning world, with every other approach sprinkled in on top of that. But yeah, I tend to use them fairly interchangeably when talking with most people because, lay understanding of the two is pretty shallow, I think sometimes.
Yeah. I think for me, I think ML is a closed loop system, right? So it came from the IoT world, or possibly maybe one of the channels, where it's really efficient at operating on a very controlled system repeatedly. It's like, okay, do this, do it very well, and do it forever.
Yeah.
That's ML. And it's the best. It's the leanest and the most efficient at doing that.
Yeah.
I think AI takes that same model and says, okay, well, what are the other outputs from it? Is there anything else we can learn from that we didn't expect?
That's a really good
there's an
point.
output module there, right? Things like maybe in your world it might be anomaly detection.
Yeah.
Or something. It's like, okay, I was trained on doing this, and I'm doing it every day. That's ML. If you're like, wait, there's something else happening here, and that's turning into a pattern, and I'm recognizing the pattern, that new pattern would be an example in my world of AI.
Especially the decision-making capability, I think, is something that we lean pretty heavily on, with some of our models. For example, sometimes we'll use a classification model to help us decide what sort of approach we need to take from there. And this kind of goes into some specific uses of the technology. We tend to do a lot of, like, I like to call this like big brain, little brain sort of processing of information, in which we'll use, kind of a big brain perspective to initially decide, how, what it is that we need to do. So if I'm looking at a picture and I'm like, oh, these are cars or these are dogs, I might have a different pathway that I need to take on my small brains, my little brains.
I see.
And so, then I'll go down to a specific model that's, maybe using, some segmentation or object detection approaches to really analyze, that specific image. So there is kind of an AI component to that of deciding how we need to process, but then I think one of the things that we've developed at Rewire that I'm excited about is our ability to ingest the new data that are coming in, especially in those little brains. So we're able to see new image types, learn and expand our capabilities from that, and then deploy new models to our users, that provide a better experience for them, better detections for them, which is definitely down in that ML world because, we're just churning through this, in a kind of a continuous learning pattern sometimes.
Yeah, clearly I think it sounds like your customers want an ML solution, right? They've got a very specific input and output they're looking for.
And it goes back to that need. What is the customer need? What is the problem that they're trying to solve?
But the classifiers, so you've built classifiers to start with, which individually are ML models. But there could be an AI model sitting on top of those classifiers that says, wait a minute, there's an 8th channel, and you said I only had 7. So what do I do with this?
That's a really good point, and I know that really fits into some of the applications that you have. Especially seeing different types of information coming down the pipeline and saying like, that's something that we need to act on. For us, kind of that high level of just pathway A, B, or C helps us be more accurate in the next step without having to create some sort of general object detection model or something like that probably isn't very good at detecting any one thing, but it could detect a lot of things all right? That's what we try to avoid.
Right? So let's go back to that example where you've got a classifier, you've got a whole bunch of classes there, and an AI is watching those and it finds a new one. Now, what do you do with that new one? Do you now go back through your data and reapply? Does it change the classifications that you already have? In other words, does it steal some information from, let's say you have 7 already, and you've found a new 8th. Does that 8th stand alone and it's clean? Or does it steal some from the other 7, in which case you've got to go back and retrain everything?
That's so that's one of the things that we first took a patent approach to, is our ability to kind of ingest the new data that are coming in and automatically learn how to transfer learn, a new capability, or transfer learn from one of our previous models to a new capability. And so that is kind of, that expansion. I think, the approach that the philosophy I think that we like to take at Rewire is that we want to have a lot of models that are very specific to that user or that use by the user. So that expansion is just really like in our DNA. I hate saying that, but it's in our DNA. We want to continually expand our specific capabilities. And I think that's sometimes a different approach. I was actually just down at a great conference in San Francisco where hearing from some of these like Fortune 500 companies that are taking just the opposite approach, trying to create really broad models that can deal with every possible solution, even across different like data types coming in. So this is like kind of getting to like the general AI sort of approach. And I think in some applications that can be really successful, but there's certainly a lot of problems that come up with it. It doesn't feel right for us.
It doesn't seem natural, does it?
Yeah.
It's just it's like a vehicle. You look under the hood. It looks incredibly complicated until you look at each individual operation that's going on. It's actually pretty simple.
Yeah.
There's not much.
Yeah.
There's not much to it. Each function is okay, but I think the idea of just one, as you said, the AI dust that just solves everything, may be a bit of a stretch.
Yeah.
I think it's more likely to going to be a whole series and a whole kind of orchestra of different AIs to solve the problem.
So it certainly makes sense in some applications. As we move into clinic, that's one area where we really want to make sure that we have a very specific AI for that very specific application. Anything that's having to go through regulatory approval has to be cordoned off. It has to be static, yes. And that is a great way for us to make sure we're not messing with the rest of our system. Just to say, aha, I'm training this one clinical model, and we're gonna have this approved on its own.
So that's really interesting and very important, right? In that that's a model that, by its nature, cannot change.
Yeah, exactly.
So AI for that application is not a good fit at all.
Yeah.
Right? But an ML, a really nice, robust, reliable, time-tested solution.
Yeah,
is perfect.
That's a good way to put it, right?
Yeah.
That is one of the good differentiations.
Well, it's one I think that a lot of people might think that AI is always superior to ML. But in that situation, ML is clearly superior to AI.
Yeah.
You certainly don't want your computer system thinking outside the box and
That's
coming
right.
up.
Yeah, that's a situation where you don't want to see changes.
Right. I think the other misconception as well is that AI is self-learning.
Yeah.
Can be.
Yeah.
But boy, that's a high bar to reach.
We run into that quite a bit, especially since we toe the line of kind of this continuous learning capability, and then providing a static inference model back to somebody. That does become really confusing, and I think as an industry, that's one of the things that we need to work on in terms of how we talk about AI in a lay setting, is that this isn't Westworld or something like that, right? Like
right.
We're a lot of times creating just an algorithm. We're creating a program that does something. It goes from A to B, and that is often, for us at least, deployment of our inference model. Mm-hmm. We will use some of this continuous learning capability to see where we can go, see if we can get better and better. But yeah, when one of my researchers or clinicians is using our detection capabilities, we want it to be dead on each time, and we don't want that to change for them, because that changes the output of their data. They may not know that it's changing. That's a real problem.
Well, and the scary thing is it could change the output of all previous data.
Yeah, you're right. Yeah,
Now you've already got results issued. You go back and redo those. So you need something really robust in your application.
Yep,
Yeah.
I think that's right. So when you're detecting anomalies, that's kind of going back to decision making, finding signal, where you weren't expecting it. So how do you address that there?
It's multifaceted. Again, you've got that operational part, which is more of the ML, compartmentalized, right? There's lots of them running concurrently. So you can say, okay, this one channel is monitoring this one sensor input, for example. And that's fine. It's just sitting there. Now the time base may change, right? So what you do with that data, because the fact that it's monitoring a particular channel and the fact that it's doing something, well, where does that information go? Especially if it's a live stream. If it's an image, it's good, because you've got one image you're pulling in and you've got a static output there. But if you've got a real-time input, what's the output?
Right.
What do you do with that? And I think one of the problems we have today is that we stream it to the cloud because it will be useful one day. Well, maybe not, right? Maybe we're just streaming a whole lot of data that we don't need out there. So that's another interesting part of either ML or AI, is what do we do with the data and what is a valuable output?
Yeah.
it's just streaming and storing okay? Analyzing and producing a report every now and then, is that okay? Or do we want to do something more? And is it the correlation between that input and something else? And I think the correlations are super important.
So what you're saying is kind of having that fire hose of information, of data coming in is, really not providing any actionable output. What you're doing is then watching for signals in there that you might not be expecting and pulling those signals out and acting upon them. So now it's not just, here's all the data, it's whoops, now we're seeing that, for example, maybe a network intrusion, right? Something that popped up that you wanted to have seen just from in and out traffic.
Well, I think, being as it's today, we've still got a lot of compute power going on in the cloud. And I think that has to change. I think the push towards the edge is the right thing to do. Well, we've got to do that computational work at the edge because you can't just store the data. So an analogy would be, raindrops falling. Well, I don't need to store every single raindrop falling from the sky. But what are interesting are the ones that hit a rooftop. A number of those hitting a rooftop, I can tell the angle of the rooftop and where it is and how long it is.
Yeah.
And the street down below and a tree and that kind of stuff. The other raindrops, not so much, right? So I'll store the data, the high value data, the raindrops that interact with something.
Yeah.
I'll store that information because it's nice to know there's a roof and a tree and a street. But I don't need the millions of raindrops that just fell from the sky. I can ignore those. Well, maybe I'll store a couple of them because it's nice to know what direction gravity's pulling or something else like that.
That's a really good analogy for that.
But I think that's some of the basic edge compute that we've got to do, so that we're not just storing all these wasted raindrops in the cloud.
Yeah.
And then we can do proper analysis on, what is going on with the tree? What's going on with the roof? Now we've got data that we can actually start using then, richer data.
And so then, those data sets that are coming in, are those, what sort of actionable, insights are you giving somebody? Are you providing the ability to create, standardized decision making or anomaly detection, or where do you think the important application of your technology is?
The applications for me are I'm just trying to push the edge a little bit, right, and push the technology and the science just a little bit to where we're looking for faster analysis of patterns that we didn't know existed. So more correlations, more complex data processing, and faster, because it doesn't work if it's too slow, right? It's got to be efficient. It's got to be super lean, super efficient. But I think one of the easier to achieve upcoming one is this correlation of different inputs, where we can say, okay, great, we've got a data feed, we've got an ML engine running, and it's processing for us and it's providing an output. What are the cause and effect or the interactions of that output, right? Can we correlate that against another data set?
Yeah.
And then then that data set also has its own output, which is meaningful and useful. But now what if you then take those two and combine them again?
Yeah.
It's just like each one was a little transistor and you keep stacking these transistors up into something more interesting. Now, where is it going? And
you're building a bigger and bigger picture.
Yes.
Yeah.
Yeah.
I think that's really fascinating because, in some ways, we're using very similar technologies, but, even the endpoint that we're trying to get to is often, pretty different. For the application of Rewire's technology, what we are born to do is to provide, a standard result and to remove bias, remove any sort of deviation, which is just kind of focusing in on, this problem in our healthcare setting or in our research setting where, we have a whole lot of, human input or human bias that often, pops up in analysis, and we're using AI just to do the exact same thing over and over again, in kind of these robotic processes that are sometimes hard for people to do. So, it's a great, I think, picture to paint of all the different ways that you can take these technologies, just to find, these two outputs here.
Yeah. I think it's interesting you mentioned bias. That's an important thing for anybody to consider. There's always bias.
Yeah.
Always bias, right? I think it's almost impossible to remove bias. It's how you handle it is important. One of the things that we're working on right now is a bias detection. It's a fancy, basically it's just an idea of metering how much bias you think you have with the current input.
Interesting.
It's really fairly basic, but I think it's super important.
And that's an application in like sensor input or in like
anything.
Big data processing?
Right.
Or?
Well, we'll take your example.
Uh-huh.
So you've got an image that somebody provides to you.
Mm-hmm.
Do you know that's indicative of, as one sample, was it indicative of the larger set or not? Was it biased, whether intentionally or unintentionally, on that? Well,
great example. Yeah,
you know?
We run into that a lot of times. Especially when trying to train models, customizing models for particular applications. Yeah, if we are looking at all green images and then the person is expecting to, bring green and blue, just for example, then that's going to be something that we really weren't anticipating in the beginning. So now we have a model that's biased for green, and that's skewing the sort of results that we're giving to them, which really I think has a big impact on the false positives that we give somebody. Usually that's where we see that sort of thing come in.
Yeah.
But I think one of the interesting parts of bias is that we're also using it, right? It like you said, it's an essential part of the system, and I don't think it's something that we can do without, because I need somebody to show me specifically what they're looking for, and that sometimes is biasing what the model would have done on its own, right? We are biasing to that particular endpoint. It's just that you want to be as conscientious as you can. You want to be aware of the biases that you're putting into it.
Yes.
It's the ones that you don't expect that cause problems.
To me, it's a little bit like tolerance. Mm-hmm. Tolerance as in the bandwidth on that, right? You could say, okay, this is the dimension I'm looking for, but this is my tolerance. It's always going to be there.
Yeah.
It's impossible. For example, in metrology, you can have 2 points on a line. Sure. You can't have 3 points on a line. Impossible, right? There'll be two on a best fit line. That third one, in real life, will never be on that line. One of them is always floating. It's inferred. So there's always a tolerance to everything.
Yeah.
There's always bias in data. The question is how much, and does it affect the model or not? And I think just as it is with mechanical engineering, it's nice to know what your tolerances are, if they're stacking, just as you can with bias stacking.
Right.
To be aware of them, to ignore them or try to remove them in the first place, may be a mistake.
Yeah.
Right? Better to leave them in, be aware of them, and then calculate them. But right now, we don't really have great tools available for us to know what that bias, how much bias we have in our data on there. But I don't think there's not an AI dust there that's going to solve that. Everybody, yourself, myself, we're going to have to build that meter, the bias meter, to know. And also, as you ingest new data sets, you say, okay, great. My training data set was pure. It was pretty centered. It was biased, but neutrally, one way or the other. Now, as I ingest new data, is it changing? Is the bias shifting a little bit? Maybe it was a technology shift. In your case, maybe the microscopes got better.
Well, so that's a really
change something.
Interesting thread to pull. Because I think, in Rewire's application, we both benefit from that and fear it. So when we are training models to be capable of looking at new cell types or something like that, we are oftentimes working away from a bias that maybe we created in our initial training set. So if I'm looking for cell type A and now I need to find cell type B, we are expanding the capability over to cell type B and maybe then biasing it to B. But then there is a malicious risk to that, and I think this is one of the things that we had to address really early on. I think because of some of the great advice that we had from investors and from our advisors, is to watch out for those entry points where somebody could inject data into your data set that is now corrupting it. So for example, we're taking images in from our users, being able to train to that new image set. But if I'm looking for cell type E and a malicious actor is feeding me dog pictures, then all of a sudden they have potentially ruined a system for everybody else. And that's really detrimental if you're thinking about the health application of some of what we're doing. But then from a user experience perspective, it's also really bad. That's not good for our customers. And so, we took the approach of making sure that we cordon off kind of these small, these little brains that we train for people. So, when you come in and you give me a new data set, I don't let that touch anybody else's. Those are static models. You can corrupt your own data set if you'd like. You can create a bias to dogs in your image analysis, but that's not something that we'll let happen to others.
That's great. So you created a safety device, which is containerizing that data set and building a wall around it.
That's a good way to put it,
so
yeah.
It doesn't. At any time, do you go back, or could you go back and then look at the entire suite and say, okay, well, first of all, is that representative of science at large or the world at large? Or no, it's all coming from this one corporation, which I know is biased.
Evil Corp keeps sending us dog pictures. Why is this? Yeah.
Exactly. Well, one of your big clients is Evil Corp. You might not want to include them on the set. So.
Yeah, we have come up with some technologies for that. One of the easy things to do is just to see how well a new data set fits your old model. If all of a sudden you're seeing this really low fit rate, then you're obviously looking at something different. And so that can throw a flag. I think there are some good approaches to that. But I'd be curious, how you're dealing, especially you're talking about kind of the upfront, looking for those differences in data types.
Well, I think the harder question is, okay, it's different. You're creating a delta from your original training set. Mm-hmm. But surely you're stepping away from it, but are you stepping closer to actual or further away from actual?
Well, I guess
are you improving or working backwards?
Yeah, that's where it really depends on what the endpoint is that you're trying to achieve. I guess is this a data set that's going to influence anybody else? Could this be malicious to anybody else? Because if it's stepping away from what that model is trained to do and towards kind of a new endpoint, that might be the target. It might be that you're trying to train a dog detecting model, but that gets down to the purpose of it, I suppose.
Well, I guess one answer there is if it's supposed to be a dog, then you can say, yes, I'm getting closer to that. But sometimes we don't know.
Right.
So we don't know. We're running ML or AI for the first time, generating results, but we actually don't know where the actual target is, if it's in front of us or behind us.
Yeah.
So you could be working away from that.
I mean, that kind of brings up a point of just where humans need to be a part of the loop sometimes. Mm-hmm. From our application, we are often incorporating new data sets from users. And when we do that, we are really asking them to verify what it is that they're trying to achieve, the endpoint that they're trying to get to. And so, that's helping us determine, which direction we want to go, right? That we're getting closer to their to their endpoint, to what they're looking for, because somebody said this is where we need to go, rather than just letting an AI drift along and
so you have correlative data that they're providing to say this is our target.
Yep.
And then that's very helpful.
Yeah, exactly. I think in healthcare settings, in research settings, I think application of AI is particularly important to remove the places where people just don't do well, tedious tasks, robotic tasks, things that could, bring in a subjective eye on something. I mean, literally, do you see that as a cell? Do you see that as an aneurysm, or do you not? That's where subjectivity and bias, I think, is really problematic in healthcare. And, applying AI just to do that with a set of instructions, maybe not that you've come up with, but that it's learned, is really powerful, because we're, speeding up the process, we're removing all that error. And then, what I think is powerful about that for our users is a lot of times that's reducing the expense of an experiment, because they're doing it faster, they're not having to do it multiple times. In the hospital setting, that's saving lives, and that's a huge value, right? So I think having a person in there to make sure it's going the right direction is important for some of those applications.
But at a certain level, because again, you just said something that really stood out to me. There's the fact that ML does this so well because it creates the standard. Mm-hmm. You've said, using this tool set, this tool chain, I get a constant output. Mm-hmm. And it's the stability and the repeatability of that that gives the data, the value in the data.
Right.
If your tool chain was unstable or unrepeatable, the value of the data would be.
Potentially so, right? Yeah.
Drastically
If all of a sudden
reduced, right?
it's finding dogs and you were looking for aneurysms.
Right. So again, stability is key there. Another, for anybody interested in ML versus AI, that stability is another aspect of ML that's really important.
Yeah.
Because you're creating a standard, right?
Creating a
I think
standard,
some
exactly
people are not
right.
aware of that, is once a model's created,
Yep.
it is a standard. And if it's a standard that healthcare or anybody else are going to look to,
Yeah.
and they're relying on that data, because once the data is created, you say, okay, the value's 112.
Yeah.
Okay, well, is that good? What's the upper limit? 115? Where? But if you're relying on that output to determine the next step in a process, you've created a standard that everybody's relying on. Because if somebody else came in with a new one and
Yep.
it was 2 points off,
Yeah.
well, it's going to have a different output.
Well, I was, in a research setting, we find that really powerful. So I think in a lot of ways we're using, AI to create an analytic tool because, I'm processing images in this one particular, this is my protocol, I'm using this model. And not only does that allow me to do it time and time again in the lab, across people in the lab, all, the exact same, which is really important, it also allows me to give it to you. And so now in your hands, are you able to reproduce, that same experiment, those same results? And if not, at least we know it's not the image analysis part of it, right? Maybe we know it's because there was some other bias or subjectivity going on in the lab, or something went wrong. But that's where I think just knowing that you're doing the exact same, that it's an analytic tool, is really important.
Interesting. Yeah, that's really good. One other idea comes to mind, which is just the application of AI in the world today, tomorrow, and ongoing, in that it is a new tool, relatively speaking, right? It's a new tool, but it's going to be relevant in everything. Everything we do could be or will be affected by AI in some points. And I'm interested to get your feedback on that, on what you see as areas, interesting areas that were maybe unexpected, that could be benefited.
Yeah. I think it's so cool. Just as you've been talking about, there are signals, there are correlations that we haven't been able to previously see, and so starting to think about maybe fairly mundane data sets. I mean, financial records are by no means mundane, but I just love thinking about the number of different behavioral patterns, spending patterns, economic patterns that become present, when looking at financial transactions across the world. That's one of those places where I think AI is obviously being applied very well, especially detecting fraud, but is probably not one of the first things that pops into mind as a really good application of this.
That's a great example.
Tesla's driving down the street, of course, is a really easy thing for us all to see. But just all these different data sets, have signal, and finding ways to create good detectors for that is fascinating.
I think that's where the passion is, right? It's not necessarily the self-driving vehicle or the numbers. It's in extracting something from that has great meaning. And AI and ML can do that in just about anything, right?
Yeah.
Old processes, new processes, sexy autonomous vehicles, or just streaming data.
Yeah.
But I think the really beautiful thing is finding those patterns that we didn't see in there. It doesn't matter how mundane the data was or is, but the patterns are exciting. When you can see something new, like a little bit like staring into the matrix of pouring numbers, when you stare into that and you see something brand new that nobody's ever spotted before,
Yeah.
and that you can build a tool around.
It starts to feel like the possibilities are limitless. Not to be so cliche, but it's really, I think, to the point where we are just limited by our creativity and what we can imagine sometimes. In terms of how we can build solutions, the problems that are available to be solved, and it's a pretty cool time to be working on this because we have a lot of tools in front of us.
I'll take it a step further. It's like we're going to be more and more dependent on AI to do these really complex tasks for us that we either don't have the time,
Yeah.
or just we don't have the ability to do in an amount of time that is useful to us. So we're going to be dependent on these things. So literally our entire lives, sometime in the very near future, are going to be completely dependent on ML and AI. So.
I think mine might already be.
Yes, maybe too late for some of us. Anyway.
Well, Jonathan, this has been wonderful. This is really nice to talk with you. A fantastic conversation. So thanks
Great
for making the
conversation.
time.
Yeah, thanks, John.
Yeah.
Always fun.
They bring up such a valuable point with the AI dust analogy. These technologies are only as powerful as the data that is going in and only as valuable as the eyes and ears interpreting the results. It's easy to fall into a mindset of only wanting to use the best data in an AI program. But what really matters is all of the other stuff. These technologies thrive by identifying outliers and providing results that really matter. We hope that students watching today take their advice and strive to use AI and ML in a vast number of industries, that you continue to find ways for saving lives and saving resources, and that you help to create a better world.